Good afternoon, everyone. My name is Rikke Carmichael, and I am the head of air operations for Network Rail. I am here today with two of my colleagues, Sean Leahy, who is one of our National Aerial Survey Specialists, and Bradley Sparkes, who is our National Drone Manager. They will be sharing with you some of our plans to improve how we capture aerial derived data, both using our helicopters and drones. Over to you, Sean.
Okay. Just move that forwards. Woo! Thank you for the heckling from the crew at the back there. Hi, my name's Sean Leahy. I'm one of the National Aerial Survey Specialists. So I predominantly work on the helicopter. As you can see on the slide there, many of you know our system called Route View. Route View's been around for about 10 years. The technology we're using is about 10 years old. Technology has changed, so that's what you see on Route View now. And of course, when you open the photo to its full size, that's what you get. It's good. It did what it had to do, but times have changed. So, with some funding and some help, we've looked to the future. So if you look at that footbridge, here's the same footbridge, taken with a slightly different camera. And this is what you actually get. So with this, we can get into optical character recognition, start reading nameplates on structures. We can start looking at our asset. We can start doing asset identification. We can look at such things as vegetation management, start doing species identification, working with partners, many of which are in this room. This is about making the data that we give our clients, which is yourselves, which is our teams on the track, better information. The better they are informed, the better it is for them. But of course, the way the camera will be set up, it won't be one camera. It may be 5, however, I can see a man over there going, it may not be, but it may be 4. But what that will be able to give us is this. So Route View 2, or the son of Route View, or whatever we want to call it, will be able to give us a 3-dimensional fly-through of your site. Not only will it give us a 3-dimensional fly-through, again, by attaching asset data to this information, as the asset flies through your screen, you'll know what asset it is. As you can see, we're coming up to a half set of switches laying there. It will be able to tell us if that's a CV switch, DV switch, whatever switch it is. And then come to a failure and you need one, you'll know where there is one. So you'll be able to get out there. This coupled with AI will again allow us to look at species identification, Japanese knotweed, Himalayan balsam, ash dieback. All of these things are very prevalent to the railway at the moment, and they're not going to get any easier for us to find. They're only going to get worse. We won't be using hyperspectral. We'll be using near-infrared. Hyperspectral is a great system. However, we need days like this. At the moment in the United Kingdom, this is a rarity. So clear, sunny days, we don't need for photos. Photos will do everything we need for us. But what we can give you now is things like this. So can anybody guess where this is? Just as we're flying through. So this is Glasgow Central Station and the approach. It looks really good at the moment, but of course as we fly through it, I can then tell you how big it is. It's that. And we can zoom into that level of detail. This is just on the screen now. You can get into that detail. Again, matching our asset database with what's out on the track will help us not only realise what we actually have compared to what we think we've got, but we'll also be able to match with what we don't know we have. There's still a lot of assets out there that we don't know are there. Again, we can go forwards to Edinburgh Waverley Station. And again, if we click and fly through it, we can look at the detail we can get. This can all be zoomed in on. You can look at station roof inspections from these photos. But this technology exists now. So we are here to give this to you now. It can be done with drones, and the beauty of the new system that we're building is it's not for today's drones. but it's for tomorrow's drones. It will be fitted to the helicopter, but as BV loss becomes a reality and larger drones become available, we'll be able to put this onto a drone. So one final fly through that we have here. So this is Cowlairs West Junction. And these are pretty photos and they are really good. However, they're there for a reason. So Cowlairs West Junction was marked up for a double lift with a stone blower. In fact, with 2 stone blowers. However, the job got cancelled. But the manager of the stone blowers wanted to be able to show his staff what it looks like when it's marked up, because it's quite difficult to mark up. So again, if we look again, he can use this as a teaching aid. And from this, he can then teach his staff how to mark up for complicated lifts, where the long bearers are. Again, all of this is available from the helicopter at this moment in time. However, we will be transitioning in the future to drones. And with that in mind, I hand over to my colleague, Mr. Bradley Sparkes.
Cool. Right. Hello, everybody. So Bradley Sparkes, National Drone Manager at Network Rail. Fairly new to the role, so I've been here for about 6 months, but today I'm going to talk a little bit about how we use drones today, which you may be familiar with, some of the kind of different use cases such as inspections, and looking forward to the future, so kind of beyond what Sean was talking about, where today we can only fly drones in a limited way, and how we might be able to fly them much further. So I wanted to start with the first slide here, which is just a slight flavour of how many operations are taking place today on our railway. So I believe this covers like a 6-month period or a 3-month period. We're seeing a large number of flights on a daily basis, kind of in the 20s to 30 range. And that's just Network Rail pilots. We have a number of kind of contractors also flying around the railway. So this here represents a significant increase in the number of drone operations around the railway. So just within Network Rail over the last 3 years, we've seen a 500% increase in the number of activities. And that's obviously a massive benefit in terms of taking people off track. Also, from a compliance point of view and how we manage that side of things, that's also a bit of a challenge, but it certainly has many benefits for us. So I just wanted to start with, a flavour of business as usual. So this photo here is just from a recent flight down kind of near the Portsmouth area. I don't know if you can see on the screen there's like a little red box. So this wider scale photo is taken from like 50 meters up. And then if I clicked through to the next photo, you can kind of see the level of detail we're getting today with inspection drones. And if we move to kind of more of a track environment, so you can see the red box in the center there again, we're getting this level of detail from a drone every day. And you can obviously imagine the benefits of this kind of type of drone application. So stuff like inspections, asset identification, route proving. It could be enabling works before a team mobilise onto site to do maintenance, all manner of different applications. We also do surveying, thermal imaging, much like the helicopter payload. So you can look at stuff like point heaters, turn those on, see if they're operating properly. You don't have to send people out onto track. All these different applications, and they are very much business as usual today. The big challenge today, though, is what we call visual line of sight. So the Civil Aviation Authority are our regulator. They regulate everybody who wants to fly a drone. We can legally fly a drone, until recently, up to 500 meters away from ourselves. That's not necessarily much of a problem in most kind of applications of drones because we're just doing a simple inspection. But obviously to realise the real benefits of the technology, we obviously want to fly much further. So Network Rail were involved, ran their own trial of a beyond visual line of sight flight back in 2019, I believe, or 2021, sorry. To do that, we had to kind of put in place a temporary danger area. And the whole idea around that is to deconflict the flight with other kind of aviation users. So general aviation, people flying airplanes, helicopters, that kind of stuff. That process in itself took around 7 months to get approved. And that's just the actual documentation side of things. You have to go through a whole consultation stage of speaking to different kind of stakeholders. They kind of have to have the opportunity to kind of say, we have a model flying club and this is going to impose this restriction on us and that kind of stuff. So it's not straightforward at all. And as you can probably see from the 7-month process, that's not going to enable business as usual beyond visual line of sight flights. So that's clearly not repeatable. The Civil Aviation Authority are actually trying to push forward that kind of beyond visual line of sight application of drones. There was a recent publication, CAP 2533, which came out, I believe, in February, around that time, earlier this year. And they're looking at the kind of whole concept of how we can deconflict drones with other air users. And 2 of those kind of approaches to that are outlined on the screen there. They are effectively detect and avoid, and an atypical air environment. So I'm going to just talk a little bit about those 2 approaches. Detect and avoid, if I just go back a couple of slides, is effectively this. So today, detect and avoid is using your eyes to look for other people that are flying around in helicopters and aircraft, and deconflicting your drone yourself. Oh, sorry, this slide. So you're using just your eyes and your ears, basically, to deconflict the flight. But when you fly further away, how do you do that? You can't see your drone anymore. You can't hear the kind of local environment anymore. So the kind of 2 approaches to detect and avoid are basically using systems like radar that have existed for a long time in general aviation to kind of look at helicopters, to look at aircraft, and potentially other drones as well. But also other sensors embedded with that radar system. So potentially we're looking at installing beacons along the railway corridor at a set distance, and rather than using your eyes and your ears to look out for other aircraft and deconflict your flight, you're using those sensors. And that sensor feeds back information to the pilot to kind of manually intervene and deconflict with another aircraft. Ultimately, we may get to a position where that deconfliction is a little bit more automated. So the information is fed back to the drone or the controller itself, and there's some level of decision-making made by the aircraft to kind of avoid the manned aircraft or even another drone. The other kind of approach to beyond visual line of sight, something we are also exploring, is something called the atypical air environment. And as recently as 2 or 3 weeks ago, the Civil Aviation Authority approved the first use case of this in the UK. So the idea here, where you have some sort of infrastructure like national grid pylons, the idea here is that itself is almost a deconfliction measure. Generally speaking, things like that are on aviation charts, and manned aviation would avoid flying near those kind of assets. And the idea could be that the same applies to overhead lines or other kind of vertical infrastructure we have around the railway. In this case, there was a national grid as part of a kind of consortium, including Seize AI and Keen AI, who we have a representative from today, managed to get approval for these types of flights. And they will be doing kind of inspection of these power lines all across the country. And then also looking at the kind of artificial intelligence, machine learning side of detecting things like corrosion and stuff like that. And again, there are so many use cases around the railway for this type of technology. We are specifically ourselves pushing forward 2 trials for beyond visual line of sight on the railway, and we're hoping to kick those off this year, so perhaps starting late this summer, kind of autumn time. The first of those will be using the atypical air environment approach, and then the second longer term project will be looking at the detect and avoid approach, and that may entail installing these kind of beacons in the railway corridor. And yeah, we're hoping that will progress rapidly. The actual initial use case for those flights this year will be kind of around the issue of trespass incidents. So the idea could be that you have a drone fitted in a box, and that could be installed at the site of a trespass hotspot. And then you get somebody call in, say the train driver, a reported or a suspected case of trespass. You could potentially send out the drone to respond and go and kind of prove whether that's a false positive, whether the line is blocking, then whether the BTP or the MOM needs sending on track to kind of go and intervene, or whether it's just a false positive and actually we can keep the railway open and avoid, obviously, Schedule 8 payments and lost minutes and stuff like that. And yeah, that's pretty much it.
Brilliant.
Cool.
Amazing. Thank you all so much. And I think the fact you've got a nearly full theatre, last session of the last day, is a real testament to how interesting, obviously, people find this topic. And it is a really interesting topic. So I wanted actually to start by asking you, how many people so far at Rail Live have asked you for a helicopter ride?
Everyone.
Every single person?
Every person, yeah. And the other question they ask is, how do we get your job? That's the other one. So.
Okay.
No one's asked for a drone ride. I don't know.
Oh, I think weight capacity might be a bit of an issue there.
Today, maybe.
So yeah, you can't offer people helicopter rides then, I'm assuming.
Unfortunately not. No.
Unfortunately not. Well, never mind. At least we tried. Those of you who gave it a go, completely supported. So I'm going to open up to the audience for questions in just a minute. But I wanted to know, and again, open to all of you, so feel free to jump in at any point. What's the most difficult part of your job in terms of operations, in terms of safety, you know, across the whole piece? What's the most challenging aspect of work like this, of aerial work?
I think from the manned side of it, you know, the helicopter side, especially for the crews, is the fact that you're never at home. You're working away all the time. It may sound like the greatest job in the world, but we actually are the gypsies of the sky. My national colleagues will be here today, Manchester tomorrow, somewhere else Saturday, and from that, the problem comes is if when we go out and do a job that's an urgent job, is how do we get that information back as quickly as possible when we are stuck using Holiday Inn Wi-Fi, or you know, we don't have the country hasn't got the infrastructure yet for us to actually quickly disseminate the information to the people that need it.
Yeah.
And for us, it's very frustrating, especially, you know, yes, we can block the line from the sky, we can speak to control, you know, from a safety point of view, we can do it really quickly. However, if there's a picture that the engineers need, we can almost live stream it, but we can't because the 4G network, 5G network, you can't even get phone signal here. Yeah. So and it's a very frustrating moment for us when we know that information needs to get back as quickly as possible.
Yeah. Yeah, hopefully that's something that will improve with things like Starlink. Yeah. But that's still obviously in its development phase. It takes time. It's kind of still reliant on being fixed in a fixed location. Yeah. But if you can have a satellite link and a good upload speed, that might help significantly. And you could have that on the helicopter itself.
Yeah.
So.
I think another challenge that we have is that we're here 364 days of the year, because we do take one day off. And we are not used to our full capacity. So we currently have 2 helicopters, and we've got a drone capability that is growing on a daily basis. But what we need from our customer side is commitment. It is to realize the benefits that we can actually provide you as our customers. We work very closely with our customers. We see it as a primary focus to identify your true requirements, because not every solution fits every customer. It is different from various user groups within the rail industry, what we need to do to satisfy what you're trying to do. But we could provide better value for money if we had more commitments from our customers, and that's probably from my perspective the biggest challenge is to try and get the best deal, basically, so we can offer our customers again the best technology that's available.
Yeah, absolutely. And I loved the example of innovation of the potential anti-trespass drone. I think that's really, really clever. And obviously, you know, thinking about the safety protocols as well, it means less people trackside because you've just got a drone that goes out and does the job, which obviously is fantastic. And like you say, helps with the kind of possible impact on timetabling. I'm wondering, and this may be one for you, Bradley, what other innovations do you see? And this could be blue sky thinking, and I'm just generally asking, what other innovations do you think could potentially come down the pipeline in this space?
Yeah, I mean, we've had some very interesting conversations even here at Rail Live, including the use of almost like lane keeping technology on vehicles today and how that might be implemented on a drone. I can see a colleague in the back, or one of our partners in the back who we've spoken to about that. It's a really interesting novel idea using the railway lines to fly in environments where you're normally reliant on GPS to kind of control those drones, and actually maybe utilize something like a camera that's already built into the drone to kind of keep it following along a path. And it's kind of less of manual flying of the aircraft, so the person is more focused on the data side of things. So that's one of those. I mentioned the drone in the box as well at the end of the presentation. Rather than potentially flying one drone 100 kilometers, these drones aren't particularly expensive in our industry. You know, when we look at all the plant and equipment that's around at this show, relatively speaking, it's very cheap. You don't necessarily need to fly one drone 100 kilometers. You could have 100 drones flying 1 kilometer or 10 drones flying 10 kilometers. And when it comes to these trespass hotspots, we could certainly look at having these drones in boxes installed in those hotspot locations so they can kind of rapidly respond to a kind of developing incident. So yeah, I'd say those two are ones that spring to mind.
Brilliant. No, exciting future, I think. Yeah. Lots and lots of potential here. So I'd love to open up to the audience. Does anyone have any questions? Gentleman here? Oh, everyone has questions. Lucky you.
Hi, so I'm Emmanuel Kemp from Arthur D. Little. An area that I'm quite interested in and quite curious about when it comes to drones. Ian Prosser touched on this in his previous talk, actually, about new, more sophisticated ways of risk modelling, particularly around risks associated with extreme weather events and climate change. Yeah. So I know one application that's already, where drones have already become involved in this is the mapping of trees along the line side to inform, I think it's the Polestorm database, where you use LiDAR to basically produce a millions strong database of all the trees with characteristics that you can detect with LiDAR that tell you, which ones are more or less likely to come down if it's a windy day. Yeah. Are there any other applications of interest that could feed into not so much the kind of interventive stuff or maintenance and inspection, but predictive risk modelling that you're aware of, where you can use LiDAR or cameras to get that kind of intelligence?
Yeah, I think potentially geotechnical stuff. So there's a lot of kind of technology out there in terms of machine learning, looking at taking in just purely image-based data. It doesn't have to be LiDAR data necessarily. And then when you repeat a flight with a drone, looking at the subsequent kind of images and looking at detecting movements. So whether it's rocks on that slope or even trees, looking at vectors of movement, and potentially over time, is that tree, the rate at which it's moving, speeding up, or is that part of the slope moving at a more rapid pace? Maybe that kind of application.
We have the gentleman at the front here.
Hi, it's Neil Dance from East West Rail. I just wanted to ask about the line-side infrastructure that you might need for running the drones. What do you actually need to run them now and in the future?
Yeah, probably more one for our industrial partner that we're working with. So we are working with some external companies on this. I think fundamentally it will firstly consist of like a radar system of some sort, but then also some sort of optical sensing as well. I don't think it's necessarily 100% decided what that would look like, and there's a lot of IP around that kind of stuff, so I can't comment on behalf of our partners, obviously. But certainly radar being the first kind of port of call. So a lot of kind of aircraft that we see flying over this site, even over the last 2 days, are fitted with transponders, but not all of them are, and that's the biggest challenge. So you can see the majority of air users, and you can deconflict that way, but there's no kind of mandate that everybody, as far as I know, needs those transponders. So that's why we look at these alternative systems. And I think the CAA are considering a whole kind of a Venn diagram of all these different systems, if you like. So transponders, and then these kind of radar systems, maybe kind of optical systems with machine learning that can automatically detect, there's an aircraft if that radar isn't working. It'll be a whole suite of different sensors. In terms of size, it most likely is something that can be bolted onto existing kind of masts, I think. So it won't be a case of necessarily needing to install whole new masts in the railway corridor.
Brilliant. I think we had another question. Yeah.
Hello, Alex Nelson from nationalrail.com. Relatively inexpensive drones have obviously replaced a lot of the jobs that are done by helicopters, but I was just wondering what are the things that helicopters can still do that drones are incapable of doing when there's manned flight?
It's a really good question, actually. We're platform agnostic. Drones and helicopters work in partnership with each other. At this moment in time, we're not in competition, but where we will always beat drones is our endurance. What we do in an hour will take a day for a drone to do. With battery life and the current rules, and also payload. Now, the systems we use and the future system, the future system will have 4 or 5 cameras and a LiDAR. However, as drone technology moves on, it'll be able to carry that. The camera we use at the moment, the Star Sapphire, the drone, even the biggest drone wouldn't be able to lift it at this moment in time. Yeah. But the beauty of a drone is if you've got one specific site that you want to go to day in, day out, you use the drone. If you've got 200 miles you want surveying, you use the helicopter.
Yeah, just to build on that slightly as well, I might put Sean on the spot here a little bit. I don't know if you know the weight of our new camera system, but I would hazard a guess it's probably more than the maximum weight of a drone that can be flown relatively straightforward today. So there's a weight limit on a drone you can fly in a straightforward manner without a kind of special exemption, and that's 25 kilos. You can fly heavier than that, but that process with the Civil Aviation Authority takes a lot of time to get approved. The kind of payload we're looking at with the 4 different phase 1 cameras and the LiDAR system, I would hazard a guess, weighs more than 25 kilos in itself. And itself would be bigger than most of the drones we fly today as well. So, yeah.
But obviously there is a strategic consideration for this, because again, we know which direction the wind is blowing, kind of thing. But the way that we're looking at it is, as Sean says, we are not in competition with each other. We are looking at the data again, because that's why we fly. That is what our customers are requiring of us, and it goes back to our life-saving rules. The right tool for the job. And it comes back to requirement assessment and say, what is it that you're trying to achieve? But I think we are fairly safe for the next control period, with the helicopter still playing a fairly big role in that. And again, obviously what the helicopter has got on top of drones as well is that if something is wrong and we need to take somebody out to physically look at it, because that happens too, we can put a person in there or 2 with us, and we can go on site and have a look at that. And it'll probably be a little bit longer before we can do that with a drone.
Anything else from the audience? Just here?
Richard Derrick-Smith from Aegis. What do you see as the main issues to overcome to really kind of exploit the potential of aerial data? Because as we've seen from the slides, the potential is huge, and obviously it's the technology is growing and the potential associated with the technology is growing. So where do you see the kind of main barriers to widespread adoption and exploitation of that within Network Rail?
Well, it's definitely what do you do when you're capturing a big amount of data? And with our new camera system, we will do that on a daily basis. So it's a challenge to literally, where do you put it? Do we put it in a cloud? Do we have it accessible to everybody all the time? What does that mean? And how do we post-process it as fast as possible? Because, as we always say, the picture we take right now is only good right now because in 5 minutes' time something has changed. So we can't wait for post-processing to take weeks or months. We have to kind of do it here and now. And that's definitely a challenge, as one of the challenges that we're going to be looking at with our project. And it's about making sure that we can get the data in a format that is easily accessible to our customers as well. We have a system called RouteView, which I'm hoping a lot of you are going to nod about and say, yes, we know about RouteView. And it is a very successful tool because it's that simple. And that's what we want to get to with our new improved data sets as well, that they are easy and simple for everybody to use. Everybody can look at a picture. We don't want it to be complicated. We don't want it to have to be an engineer to understand what you're looking at. So again, that is one of the challenges that we've set ourselves, that what we're going to be able to provide our customers is going to be a better version of what we have today that are easily accessible for everybody. Because again, what we are trying to promote is safety, isn't it? And we are sharing the information. And the more and the easier we can do that, the better for our customers.
I think another issue is, Ricky sort of touched on it earlier on, is the actual inconsistency between our customers. So we have a good base of customers, Scotland probably being one of the best because they have their own helicopter. Their data will be updated every 6 months. But then you have other areas that don't use the facilities, don't use the helicopter, don't use the technology that we're bringing in, that won't get their data updated. And it's how do we try and push that forwards as an industry, going, look, you really need to invest in time to gather this data, because other areas are getting, leaps and bounds ahead of you. Whereas you can go onto Route View now and actually just do a little slider, and you'll see, I'm not going to mention the areas, but you'll see the areas that do not have up-to-date data. And from us, for us, it's frustrating, especially at shows like this, when we get engineers going, yeah, we love Route View, but it's so out of date. Yeah, we know that, but there's nothing we can do about it. We've told you it's out of date. We want to update it for you. When you think, if you just take the national survey, happens once every control period, and it may not happen. This is the thing. But if you think, I'll just use Scotland as an example. If they have their national survey done at the first quarter of CP6, and they don't get their next one until the last quarter of CP7, that's 10 years in the difference of the data. The world has changed within 10 minutes of that data, let alone 10 years. What we're hoping with the new system, and coupled with especially because it will have LiDAR on board, we'll be able to give them that data every 6 months. So rather than seeing massive changes, they can start seeing these incremental changes that are happening, and then be able to intervene earlier when something is starting to move, rather than, right, we're the fire brigade, let's go out there and sort this and get it done now when it's too late. It's about having that ability to intervene earlier. But some areas will have that ability and some areas won't. And it's because Route View is not a mandated system, it's an optional system, should we say.
Yeah, brilliant. Well, thank you so much. As stimulating, I think, as everyone expected on such an interesting topic. So I think another round of applause, please, for our panel.